All right, fantastic. Well, to be able to start on time, I will begin introductions. We're still getting a little bit settled, but thank you everyone for trickling in to this tech showcase today, Tuesday. If you weren't here yesterday, this tech showcase is Monday, Tuesday, Wednesday at lunchtime here in the auditorium. And it is sponsored by Business Connect, RTI, and the UNC Water Institute. We are here to highlight technologies and innovations in WASH, and we want to give a spotlight to these amazing new developments that all of you have either submitted or been a part of the development of. So we're super excited to showcase those. This year is a little different. In previous years, the technology showcase was just some friendly presentations, and we thought, what's better than a friendly competition? So this year it's actually a competitive presentation showcase, and we have 4 judges here. We have William Kamkwamba from Moving Windmills. He is one of our judges. We have Mike Fisher from UNC Water Institute. We have Jeremy Lambert, the CEO of Business Connect, and we have Edgard Gabo Ya Mentira. It's no, I don't have it written down. This is Edgard from RTI. He is a researcher there. So we're super excited and honored that these 4 judges are going to help us judge the panels today, the presentations today, excuse me. And they're based off of a rubric. So maybe we could pull up that rubric to show. Yes. So the judges are using a pointed scored rubric to decide 2 of the awards. We have an innovation award and an impact award. So that's completely decided by the judges as they watch the presentations. But then we also have an audience choice award. We can show those 3 awards if you would be so kind. We also have an audience choice award. So the Audience Choice Award is up to everybody here, and I know people will slowly be trickling in. It's like lunch line is probably super long. So as people slowly trickle in, I'll continue to just remind about the QR code and survey link that we have. But yes, maybe we'll pull that up. Here's a QR code, and then if you don't have a phone, you can go to slido.com and put in that string of numbers. And you will not submit the survey until the very end because all of the presentations are in one submission. So if you watch the presentation, you're welcome to give it a rating and then wait until the end to submit. But if you don't watch the presentation, please don't vote on it because that's just not fair. So so we have those 3 awards. We are very tight on time today. Yesterday we had a few less presentations and we're trying to fit in a little more today. So each presenter has exactly 5 minutes to present and then 2 minutes for Q&A. And I have a timekeeper up here, Christina. She will hold up a 2-minute, 1-minute, and time's up warning signs. So if you're a presenter, just make sure to glance at Christina every now and then. And I'll help to try to keep time, but don't be offended if I say, thank you so much, and I welcome the next person. I just want to give everyone the same amount of time. I think those are all the housekeeping things. We're super excited to learn about some more technologies today. And yeah, if you have any questions, you'll have time for Q&A in between, but if they're not met, then come to the Business Connect booth afterwards and we can direct you to who you are needing that question for. So yeah, thank you so much. Without further ado, we can welcome our first presenter, Immuna, a water crisis platform. So let's welcome Sierra.
Awesome. Thanks, Jamie. Hey everyone, I'm Sierra Stamey and I'm with the Immuna Water Crisis Platform. And I'm so excited to be talking today about the technology that my team and I have built for organizations getting clean water to the world. So first up, our mission. Our mission is very closely aligned with the missions of water crisis NGOs, universal access to all through our modern technology platform that focuses on the #1 problem that we have heard to date from those folks, which is unfunded water projects. And just to dig into that a little bit more, how do we plan to achieve this large mission? First, we want to foster awareness of the water problem with our technology. So a lot of people who do not have direct contact with an NGO, they are not aware that 2 billion people still lack clean water access. And just wash education, all of those things, we're wanting to bring awareness to that first and foremost. And on top of that, awareness to the work that the hundreds of NGOs are already doing to help. And including amplifying the trust that NGOs have already built with people by verifying them on our platform and being able to show the great progress and work on a map. And then lastly, we aim to mobilize donors by simplifying the donation process to make it quick, easy steps once they see the value in donating to these causes. And just a quick summary of this platform approach in general, it's looking to engage a market that may not otherwise know about the problem or what their impact and their contributions can do. And on top of that, it's with no additional effort or cost or burden on the NGO themselves. We are here to take that burden off and be an advocate and a vehicle for those organizations. All right, and so you're not just hearing it from me or our partners. Let's ask ChatGPT about the problem and our plan for it based on their data. And while that's running, you can see the results. I will spoil it that the data does agree, the AI agrees this is a problem, and it really emphasizes the need for a platform like Imuna. And just, the UN has put out a number that $114 billion are still required per year to get universal access by the SDG 6 goal. So now it's more important than ever to have a platform focused on ending that problem. All right, so enough of that. We will show live a demo of the platform in action. And Bart is going to help me out with that. Thank you. All right, great. So this is the Imuna Water Crisis Platform, and we are first going to start over to the right in the Central African Republic, where you are seeing over 2,500 water points, and these are with our friends over at Water for Good. These are indicating the water points that need funding and that the donors coming onto this platform can help achieve. So let's zoom in to Berberati, where we can see in more detail the water need in this area. If we switch over to satellite view, you can zoom in even further to get that granular look and feel and really just showing the donor how this remote location truly does need that water in this area. And so if I select this water site, it is associated to a Water for Good project within Imuna, and the donor is able to quickly and easily give from this point forward. Awesome. And if I select give, that's going to take me straight there. All right, so I'm going to go back, and we are also going to want to look at the Amigos for Christ. Oh, sorry, Bart. You know what? That's okay. I think that showed. Okay, great. So Amigos for Christ over to the left here has done some incredible work in Chinandega, Nicaragua, and they have over 200 water points on the map. These are the green ones that are funded and showing the great work that they've already done, and these are the ones that donors can fund towards. We also have a list view for donors that like to see things in very organized columns and able to compare and contrast what they want to put their donations towards once they are aware of the problem. And then lastly, donors are able to create accounts to foster that futuristic look and being able to stay around for the long term and create personas for them based on their donations. All right, that's going to wrap up the demo. Go back to the slides. Thank you. Great. And I wanted to focus a little bit of time here at the end, I think I have 1 minute, on what's next for the Imuna platform. So our main goal is staying closely aligned to NGOs and driving meaningful impact for their mission. And I really am out of time, so I'm just going to flash up. We have implemented a Stripe integration to make it embedded iframe payment so that it's minimal clicks for getting donations to the NGO and after they have seen the impact of the mission. And then there's more here, lots to come. And here's a QR code so you can explore our app on your own. So you can go directly to what I was showing. And if you are an NGO that's interested in being on the platform with Water for Good and Amigos for Christ, please reach out to my email or just come see me after. Thank you.
Okay, there we go. All right, now we have 2 minutes for Q&A from either the judges or the audience. We have, yes, thank you. We have I think we have 2 walking mics actually.
Thanks for that presentation. I got a quick question for you.
Yeah.
About sustainability. So, you know, we heard in yesterday's plenary and today kind of the sentiment that, hey, projects and NGOs and missions come and go and government sticks around. If I wanted to use a platform like yours and find out not just where can I give money for water, but where can I give money for water to an effort that is integrated with what national and local governments are doing, as opposed to maybe somebody who's working sort of in parallel outside of what government is doing. Is there a way that I could get some kind of an index or metric or icon or something that says, hey, these folks are actually talking to the government that's going to be there for the long haul?
Yeah, absolutely. That's a great question, and one that has come up already multiple times in the couple of days of the conference. Just talking with people about the platform and what it can do, what it has the potential for. And we definitely see that layer above NGOs of government being able to filter down those metrics and provide more of that trust that, you know, if donors are focused on the sustainability aspect, they can use that in their decision and how to donate. So absolutely. And also we have talked through having statuses on these projects of what is being maintained by government versus NGO, and versus completed or not funded.
Thank you. Yeah.
Do we have time for another question?
Yeah, yeah.
Oh,
for
so
sure.
yeah, so my question relates to data and funding. So where do you collect the data that you just showed us about, you know, the water problems, and who decides what projects are being funded? And how do you make sure that the funds are being properly used for the intent?
Yeah, that's a great question. It really speaks to the part of our mission of amplifying the trust of having NGOs that are vetted on the platform and then being able to show the big picture of the work that has been done versus what's in progress. And that is a large portion of what we're looking to do. Yeah.
Thank you. Yeah, I need to move along. Thank you so much, Sierra.
Thank you.
Okay, yeah. Awesome. Great. Next, we have the Mortensen Center in Global Engineering and Resilience at the University of Colorado Boulder. And I will let them take it away from here.
Okay, great. Thank you. Hi, everyone. Good afternoon, and thank you to the UNC for the opportunity to speak here today. My name is Josh Klaus. I'm a graduate student from the University of Colorado at Boulder, representing the Mortensen Center in Global Engineering and Resiliency today. And I'm here to talk to you about ShitSense, officially called the Loom. This is a in situ E. coli risk sensor. So many of you may remember during the Paris Olympics last summer, there was a lot of media attention regarding the frequently high levels of E. coli in the water where the triathlon was set to be held. This led to frequent delays and even some athlete illnesses. And in an example perhaps more relevant to the development and wash sector, a recent article has estimated that 4.4 billion people globally lack access to safe drinking water. The primary barrier to safe drinking water use is fecal contamination, which is indicated by E. coli. So these examples show that there is a need right now, more than ever, for rapid, effective E. coli testing. And that is where the Loom comes in. This uses a technology called tryptophan-like fluorescence, combined with a machine learning algorithm to estimate E. coli contamination. Tryptophan-like fluorescence is a process involving tryptophan, a naturally occurring protein, which has been shown to have high correlation with fecal contamination in natural water, and it fluoresces under certain wavelengths that this device is able to pick up. We output quantification of E. coli levels, not simply relative fluorescent units. It does not require regular cleaning or calibration due to the machine learning model. and is designed for continuous use, and its internet connectivity allows for remote data reporting in real time. So traditionally, as I'm sure many of you are familiar with, E. coli has to be tested manually. You have to grab water samples, plate them, and incubate them for at least 24 hours and enumerate them. And while this process is tried and true, it's effective, it has its limitations. It's very labor intensive, and it relies on being able to physically visit a site and grab water samples. And contamination is intermittent. This frequently happens, you see spikes during floods or rain events, which are times when it's especially hard to get out into the field and grab water samples. And TLF is able to address these gaps in the data. There are some existing TLF sensors, notably Labellium's Proteus and Chelsea Technology has a unit. And while these are functional and very useful, we believe this technology can be improved. There are some unique features of the Loom that set it apart from the competitors at the moment. First off, it is vastly cheaper. We are aiming for a production cost of around $500 to $1,000. It has a compact design that allows it to serve its purpose well for continuous remote use. It uses advanced LEDs and silicon photomultipliers that provide high quality data for a low cost point. And the machine learning algorithm is able to account for signal drift and biofouling background noise through a network of factors such as stream flow or temperature. So my work over the last few months has focused on lab and field testing of this device. I've been working in the lab to run these through graduated baths of tryptophan dilution. So we look at the device sensitivity as well as variation between the devices. And we've also had them deployed in Boulder Creek near our campus, where I collect water samples to plate and enumerate, and then we compare the E. coli levels to the sensor voltage outputs. Here's some of the preliminary results that we've seen through these testing. Your left is E. coli trait concentration versus the sensor output, which shows really high and really promising correlation, even down to low E. coli concentrations. And on the right is the output of our machine learning algorithm, which shows some of the factors that it takes into account and their relative weights. So the next steps here are to continue our validation and testing. We are excited to announce a beta testing program where we are looking for contributors, for anyone who has projects who thinks this might be a useful technology. You can scan the QR code on screen or find me after the talk here and I can show you our sign up page. And we're looking at deployment for some of our water quality monitoring programs home in Colorado, as well as abroad in Rwanda and Kenya. Thank you for your time. I'll take any questions now.
Darren, if you want to run over, or Kevin, if you got it. Thank you.
Hi, nice presentation. I'm Angela Harris from NC State. So I'm wondering, have you done any comparisons to other types of sensors? Because like with your machine learning models, you're including a lot of other like temperature, rainfall, and even just like seeing how that predicts E. coli outcomes relative to the addition of your sensor. And then like, you know, a sensor that measures something like FDOM or, you know, turbidity or something like that to show that this TLF sensor actually is an improvement over some of these other existing.
We haven't looked at that yet, but that's a very good idea and I will look into it in the future.
Thank you so much for that amazing presentation. Well, I have a little, just one question regarding the usability of the fluoropores, because I understand that these actually photo bleach with time. I don't know if you've actually looked at that, and also the sensitivity of the over spectral photoscopy in environmental samples seems to be a little bit low sometimes. I don't know if you've considered that aspect in the sensors. Thank you very much.
So the sensitivity, sorry, I couldn't quite hear the first part of the question. If you could repeat that.
So question one was on photo bleaching of the fluoropores of the fluorescent substance that you're using. Up to how long can it be used?
I see. So that's an issue we've had in lab testing. If you keep the same batch of tryptophan with the sensor, it degrades pretty quick. in natural water systems and the way this is designed, water can flow freely through it. So it's not an issue in most deployment cases that we would look at. And for the second part of the question, so the sensitivity, we've seen really good results predicting above or below 10 parts or 10 CFUs per 100 milliliter. But I can't speak to more about the actual sensitivity of it in use.
Yeah, along those lines, what would be the hurdles to get something like this accepted for regulatory purposes for monitoring recreational waters, right? So number one is, can you measure what you want to measure? Number two, if somebody wants to know about recreational water safety, but their regulator says, yeah, we just kind of need to see something culture-based. So what are your thoughts around that?
Sure. So first off, I think the continued field testing will definitely help strengthen our data. It's in pretty early stages now, and even this is still a prototype design. And secondly, its main intent is to be a risk sensor. So if you see a spike, the next step would be to go test your water and confirm if you're seriously concerned about some kind of contamination.
Thank you. We have one last question over here, and then we'll have to wrap it up.
One is, will this work in marine waters?
In marine waters?
Yes,
I have not tested that. I will look into.
because a lot of recreational waters are marine waters, not necessarily fresh waters.
Sure.
So that, I would encourage you to explore that, because there may be other interfering microorganisms that
Mhm.
would affect the performance
Right.
of your system. The other is, how effective would this system be for drinking water, where you're trying to get down to very low levels of detection and hopefully have negative results? In other words, you don't want a signal at all. And how does this work when you only have a few E. coli? WHO has a order of magnitude scheme from none to 1 to 10, 11 to 100, and so on. How would this work for drinking waters to identify the most at-risk drinking waters?
Right. So that is our primary target, is looking at drinking water. And we've seen really good results between like pure DI water and anything that has contamination. I'll have to definitely continue to research like very, very low actual E. coli levels. But in terms of lab-based tryptophan dilutions, we can see a really clear difference between down to like 0.1 parts per billion versus 0. So it is pretty effective at low concentration.
Great. Thank you. Thank you so much. Awesome. Before the next one comes in, because we've had some people trickling, is the Audience Choice Award. Just a reminder to scan that, take notes as the presenters are going, so you remember at the end to rate all of them and submit. Thank you. Next, I'd like to welcome Blue Filter, which is an innovative water purification system that leverages natural filtration techniques using a mixture of plant seeds.
Hello, everyone. Good afternoon. I'm Salah Assadi, researcher in water and environment. I want to talk about my project, Blue Filter. This project came to my mind during my master thesis. And Blue Filter, this map shows that the size of a problem globally, high concentration of nitrate and chloride in water, and international standard for nitrate in water, safe water, 10 milligram per liter, and for chloride, 200 milligram per liter. But now reach more than like 1,000 milligram per liter for some countries in the world. What are the effects of high concentration of nitrate and chloride in water? High cost for farmer to find clean water, high cost to remove nitrate and chloride from water, disease affecting both plants and humans, and desertification of green lands. Blue Filter technology, it is innovative water purification system used mixture of plant seeds treated by green technology and remove nitrate and chloride with high percent, more than 90%, without any use of any type of chemicals or electricity power. How Blue Filter works? Blue Filter works, there is like molds, these molds filled with the plant seeds after treatment. The treatment, this is our secret because now in the process to register this treatment process as a patent, then we reached to the last product, Blue Filter, as a biofilter. This system consists of 3 basins, and we can apply this system with the farmers in the field. The first basin to collect polluted water. Second basin, intermediate stage. During this stage, we can produce fertilizer and feedstock. The third basin to remove nitrate and chloride. All this system connected with mobile app to aware farmers how to use this system and to educate farmer about data during treatment system, because we know the level of education for farmers is limited. The system implemented with 500 farmers and produce large quantity of water for irrigation and increase the productivity of crops in the field. We have a proof of concept from international organization about the quality of water before and after treatment. Our competitors, Blue Filter, all Blue Filter products recyclable, zero waste, produce large quantity of water and safe for environment, no side effect. Our unique value, Blue Filter will improve financial condition for farmers because provide job opportunity. And Blue Filter, increase the income for farmers, increase the productivity of plant crops, save energy because no energy, no chemicals, and reduce the diseases between human and plants. We target market, our target market municipality, agriculture sector, industrial sector, NGOs organization. We work in for profit and non-profit. We raise a fund or our profits to develop a Blue Filter, and the extra profit, we use this profits to support like farmers in crisis area. We expect to raise fund during next 3 years, like $900,000 from Blue Filter's products. And we now looking to raise fund $100,000 because now we develop new filters to remove heavy metals and to treat salinity in water. This is my team. I'm Salah Al-Sadi, specialist in water and environment. Ahmed, administration. Samia, air and environment specialist. Tasneem, social and designer. Jen Hensel, our consultant. Thank you.
Thank you so much. Let's open the floor.
Thank you. You please tell us more about your technology. We don't need proprietary information, but I would like to understand exactly how you make your medium. How do you make sure that it doesn't get molded when it's being used? How long does it last? And eventually, how do you maintain a permeate flow if you don't use any energy?
Okay, that's a good question. There is no flow. Only we soak these filters in any tanks or any basins, big basins, before we measure the concentration of nitrate and the chloride. And I estimate how many filter units I want to use it for tanks or basins. Yeah, I put like 2 units or 3 units by soaking only. No flow. Yeah. And after this treatment process like take at max 2 days to remove nitrate with 100%. Sometimes I reach to 100% removal of nitrate and chloride in this technology.
Yeah.
How do you plan to reach farmers who lack smartphones? Smartphones, like
No, I'm working to provide farmers with the training, to help them, to give them also all technologies about how to use smartphone, because this technology is very important for them to know all data during treatment process. This is like secondary technology of a Blue Filter, because you know about farmers. If you ask farmers, what's the meaning of nitrate? What's the meaning of, for example, 10 milligram per liter nitrate, 50 milligram per liter? We need to educate farmer about this data, because this concentration of nitrate and chloride increased in the water, unfortunately, due to the misuse of fertilizers. by farmers. Yeah.
Thank you. Thank you. Yeah, we do have to transition. We're going to go quicker now, but I appreciate it so much. Thank you. Thanks. Great. Yeah, I want to make sure we have enough Q&A for everyone. So now I would like to welcome Oxfam to talk about their hand washing stand.
Hey everyone, sharing the Oxfam hand washing stand. Maybe before talking about what's involved in this, just to understand the problem and where this is for, which is situations of mass displacement. So refugee settlements, refugee camps, and sort of first phase emergency response. And if you think about the challenge of hand washing in those contexts, you have, communal latrine use, sort of dense, dense sort of market areas, places where achieving hand washing sort of behavioral outcomes is quite difficult. And, while there are options for local construction, local procurement, you really need a piece of kit that can get there quickly in those type of situations. And so some colleagues spent several years working on that to research and identify what is something that could be rapidly deployed, that would be low cost, robust, and could do that. And this is sort of the result of that. It was an iterative process that took place over several different countries: DRC, Tanzania, Uganda, Bangladesh. And it sort of had a different design over time. But this is what we ended up with. It's got 4 little taps, so they dispense a small amount of water in each go. You put 20 liters, 24 liters.
Can you grab that handheld mic on the table?
Right. I'm gonna bring this. Can you still see it? Sort of. Okay. So so we've got 4 taps here. They dispense a very small amount of water, so it's water saving. It uses soapy water and a water tank here. You can also suspend a bar of soap on a rope there. It's quite robust. Any design that goes into that type of context has got to be able to be theft resistant. Somebody will try to break it in some way. Its legs are cemented into the ground. You dig a soak pit, and the wastewater goes into the soak pit. It can be adjusted by height depending on how deep you set the legs in, so more disability friendly in that way. So quite robust. You can't really break it apart and steal it. Well, you can always break something totally, but you can't. It's quite difficult to remove the legs because of the way it's constructed. And it's got sort of the behavioral nudges. It's got the mirrors there, so one can easily, you can take a look in the mirror. That sort of promotes practice. These are set up outside of communal latrines and in market areas. Let's see what else to say. It's been used in a number of contexts, and it is deployable from our website. So the link is obscured a bit there, but it's our supply center website in the UK. And so aid agencies can order it from there. It comes in a packet of 6. It is quite packable and very light. So it's easy to deploy. It is, I think the price right now is £58, so about $70 per unit. And it's easy to set up. So it takes about 10 minutes to set up 1 unit. And then, a bit of extra time to set it in concrete. One thing to say is that, so you set it up quite easily. You can put a lot of these in different market areas, areas where there are communal latrines. And I guess kind of the big news is that, we have the crisis in Gaza now. There's a lot of need for this, and there was an order that was put in for 17,000 units. So we might be seeing these on the news soon and kind of the background once they're deployed. I'll stop there for any questions. With thanks to ELRA, the Humanitarian Innovation Fund, which provided funding for the development of this. I was not, if you can't tell, I wasn't on the team that developed this, so I'll do my best to answer the questions. Thanks very much.
Thank you, thank you. I see a question over here. Yeah, go ahead.
You know how many users do you need like to replace the water, even though like it space very little water per
Yeah.
1 unit?
It lasts about 200 hand washes,
Okay.
which if you think about it, okay, you got about 24 liters. That's not very much. And it's because of the tap. You press up on the tap and it dispenses a relatively small amount of water.
Oh, great.
Great presentation. Excited about the frugal water dispensing and the security of the system. However, I feel like you have a missed opportunity here to securely store soap as well. I mean, have you thought about bar soap theft? It would have been great to see a liquid soap dispenser integrated into the design.
It would have been, and it is, because I'm bad at presenting it. But so you open it up, it's got two chambers. So one for water and one for liquid soapy water. So the mechanism is you push up and then it combines the two streams. It does have, so it's not, it's hard to see. There's a little thing here and you tie a string and you can do soap on a rope if that's preferred. So both options are there.
Fantastic. We have time for one more question. Thanks. Yeah, Mike.
Yeah, so basically if you set it up like this at this height, then difficult, but you could set up two and you set up one at a lower height.
Fantastic. Thank you so much. Appreciate it.
Thanks a lot.
Yeah. Oh, thanks. Yeah, I like how we have very physical things to show this year. Great. And next we have MetaMeta Smart Center Group presenting supported self-supply, an approach to reach SDG 6.1 in rural areas, show of a locally produced EMAS drilling tool and a locally produced EMAS pump.
Hello, so I'd like to share some information on scaling self-supply or scaling access to water with supported self-supply. We all know the problems in Africa, in rural Africa. 300 million people lack basic service, which is an improved water source within 30 minutes walking from home. And many pumps are broken. And if you want to supply basic service to this group, it would cost at least $15 billion. And we think a better option is supporting self-supply. So use the willingness of people, of families, to invest in their own water system. And if you would do that, we think, and our experience is that you can do it for half the money and with more sustainable results. So what is supported self-supply? Supported self-supply is, we think, the combination of training in innovative technologies that you can produce locally, but family-owned wells and systems that is shared with 5 to 10 families, using the water for income, so productive use like irrigation or livestock. And to reach the poorest, we need subsidies. So some examples of support self-supply. In Zambia, we had funds for 600 subsidized wells. And these wells that cost average $1,000 served 40 people. So after 6 years, what we see is that over 90% of these wells are functioning. But it also created a demand for people who would not get a subsidy to pay wells themselves. We had similar experiences in Tanzania. There was 700 subsidized wells. We trained local private sector in well drilling and pump production. And there's now over 15,000 rope pumps, and 80% of them are fully paid by the families themselves. In Nicaragua, we started 30 years ago with this concept. And by now there is 50,000 rope pumps that on average generate $220 per family per year, additional income. So over the last 20 years, These rope pumps together have generated over $100 million. And that was a result of $2 million in funding for training. So if you want to have self-supply, you need low-cost technologies. So this is a range of low-cost technologies. I will not explain too much, but this is one example. This is a scale model of a rope pump. Old technology, but with new materials and with a business approach, it is very effective. There's over 130,000 in the world already. There is Amos pumps, which is probably the cheapest hand pump. It fits in a very small borehole, and it can cost, on average, $10 per meter. And also there is smaller solar pumps. There's a range of small solar pumps available. So these are some numbers. So it's not small, it's big. If you scale it up, it can become really big. And the key for success is that they are market-based, that they are repairable, that the ownership is with one family, that there is profit, but this all takes training. On the right side, you see a rope pump. We had 200 rope pumps in Ghana, and after 1 year, 80% was broken. So you need to do training and quality. So the result of supported self-supply is reaching SDG 6, but you also solve the pump maintenance problem, and you have impact on poverty, food, gender, and climate. So we think if we shift from imported to also local, from communal to also family, and from domestic to also productive use, we can really reach SDG 6 in Africa. Thank you very much.
Thank you for all the demonstrations too. Any questions from the audience here?
Yeah, my question's around scalability. So you talked a lot about the training side. Is your scalability method then really in the training of the producing them locally and all those things? So what is your scalability solution for this?
Yeah, so the scalability is basically two things. One is training and training the private sector. We don't train, well, we need NGOs to support the training, but we have seen that if you train people from NGOs, they stop when the donations stop. So you need to train the private sector. That is key for sustainability. And you need to have money to create what we call the critical mass. If you put one rope pump in a village, they see it as a curiosity. You need to install at least 5 to 10% of a certain product before other people say, hey, I want this also. So you need funds for both the training and the critical mass.
Edgar?
So when we think about manufacturing at scale, what is the main cost driver for these products? And how can you make sure that these can be locally sourced?
So the last question was what?
How can we make sure that all these products or this product can be locally sourced?
So that is where, again, you need the training and you need demonstration. You need to show things. And that is another topic that will be touched by this innovation hub, for the wind energy that is happening tonight. So you need local innovation hub. You need local training centers where you can train people in these technologies and give options to people. We don't say this is the best. We leave the options to the people themselves. So you need training centers that have the demonstration and have the capacity to train the local private sector.
Great. Thank you so much.
Yep, thank you.
Excellent. Great. And now we have the University of California, Berkeley with the Turi Tap.
Okay, hi everyone. My name is Jeremy Lowe. I'm a PhD student at UC Berkeley. I'm joined on stage by Dr. Amy Pickering, Dr. Yoshika Kreider, who are going to help me with some of the demonstration that we'll go through today. And I'm presenting on the TerryTap, which is a kind of passive inline chlorination technology, which we believe can greatly expand access to safely managed drinking water. Many of you previously knew this as the Venturi, but we've since rebranded to TerryTap, and we have a lot of exciting updates to share with you all. So I'm going to start by just talking about the spectrum of water treatment technologies that are available to us today. And so on one end, we have centralized drinking water treatment and distribution. And this is kind of the gold standard for how we treat drinking water today that provides the highest quality water. But this can also often be cost prohibitive in many low-income settings to implement. On the other side, we have point of use water treatment. And these are often like household level products that allow individuals to take advantage or take control of their own water safety, but often this can come at their own financial costs and time costs to treat their water on a regular basis. And in between these options, we have point of collection drinking water treatment. And these are community level drinking water treatment solutions that are able to treat drinking water at a central community point and provide and distribute that financial and time costs of operating and maintaining these systems over an entire community. And this point of collection drinking water treatment is the kind of technology that the TerryTap is. And for more background as well, and why inline chlorination has a lot of potential is that there are currently over 2 billion people that use drinking water points that are microbial contaminated that are currently compatible with inline chlorination. And this is further important because there was a recent study that came out in Science in August by Greenwood and others that shows that fecal contamination particularly is the primary factor that is limiting access to safely managed drinking water today. And it affects almost half of the population in low and middle income countries. And this leads to the TerryTap. And so the TerryTap is again a point of collection drinking water treatment method that relies on passive inline chlorination. And so passive meaning it doesn't require electricity and there's no moving parts. There's low user burden and low operation and maintenance daily. And what I mentioned as well is that this particularly attaches well to like any existing tap connection, central storage tanks, et cetera, at community points. It's compatible with a variety of flow ranges, 6 to 60 liters per minute, and it primarily relies on using liquid chlorine. And we use this device primarily in like sub-Saharan Africa, where there's a wide availability of liquid chlorine like WaterGuard. And we've also piloted or worked with this with electrochlorinators as well. And so we're able to have on-site generation of chlorine to supply the TerryTap. And so there are a few things I want to highlight about our prototype or our sample here. And so one thing I'll highlight is that we have a large storage capacity for liquid chlorine. We can hold almost 3 liters of liquid chlorine, which gives us several weeks between refill time. Another thing I'll mention is how we control the dose. And so there is a needle valve, which allows us to finally calibrate the amount of chlorine that we want dosing into the water. And water comes in through the back pipe and out of what is known as the Venturi apparatus, which relies on fluid dynamic principles to passively pull in chlorine as water flows through that line. And the last thing I'll mention is that refills are super easy to provide. You simply just open the top of it and you add in your liquid chlorine, whether it's WaterGuard or another source like electrochlorinator, as Amy's presenting. And just to wrap up, so this device has a long history. And so previously it was known as an Venturi. We've done extensive evaluations of this, particularly in Western Kenya, both in a 2019 study where we demonstrated effective demand among water kiosk owners that wanted to treat their water using this device. And also we've conducted a long-term evaluation of prototypes over the last 2 years in healthcare facilities in Western Kenya as well. And that leads us to where we're at today. And so we are moving from prototyping to scale. And this is something that we're really excited about. So we are setting up manufacturing currently, and we're expecting our initial production run of 200 units to be completed by January 2025. And we have our distribution and sales partner, Davis and Shirtliff in Kenya, who begin distributing and selling the TerryTap in Kenya in 2025 as well. And there's a QR code here as well if you're interested in manufacturing updates. We'd love to connect and talk more about this with you. Thank you all.
Great, thank you. Love the use of nonverbal demonstrators up there too. That was great.
Really nice presentation, and I like the showcasing of how it all worked. So how do you make sure it doesn't like over or underdose, like it's the right dose for the water quality and like, yeah, that's.
Yeah, I could talk a lot more about the dosing mechanism. So primarily it relies on, like I mentioned, a fluid dynamic principle called the Venturi principle. And so as water flows through the pipeline, the amount of flow that you have going through the pipeline is proportional to how much chlorine that you're then pulling into the line. And so if your flow rate varies, it still is able to maintain a consistent dose. Yeah.
Someone's setting this up for the first time. How do they make sure that it's getting the right dose? I
Right.
guess.
Yeah, and so what they'll do is they'll set this up, they will set it up, they'll dial in that needle valve that I mentioned briefly before, they'll take a water test, they'll see the dose that they have, and then they'll adjust the needle valve accordingly. And so by finally tuning that needle valve, you're able to go from like maybe 1.5 milligrams per liter to what you want to target, which is like 1 milligram per liter.
We have a couple questions, and let's prioritize one of the judges. Thank you.
Great, thank you. Yes, I had actually a similar concern about safety. You are using liquid chlorine, if I understand properly. So how do you make sure that chlorine keeps its potency over time?
Right. So like I mentioned before, this has like a 3-liter liquid chlorine like volume in it. And so what's happening with the chlorine is that like over the period of like several weeks, that will deplete over time and you're replenishing with like a fresh stock of chlorine. And like that 3-week time period is not like a significant amount of time for the chlorine to decay significantly inside of there.
Great. So I saw one there. Oh, great. Okay. So last question over here.
So my question has to do with what happens to the chlorine once the user collects the water and takes it home? What do we know about the loss of chlorine residual in homes? This has been repeatedly observed in some other kinds of studies. And what is the opportunity for people to store water in which the chlorine disappears and they keep using it?
Right. So I think, like as we know with chlorination, like the big benefit of chlorination is that you do have that residual protection over time. But I understand like what you're saying is that that residual eventually will be depleted, and that's correct. But I think that is where you come into consideration with what you're setting your original dose to, so you can kind of buy more time and counteract the chlorine decay, so that you're then able to store water for a longer period of time.
Is there any guidance to those who collect water about how to properly and the chlorine properly refill the water as needed so that they do have water that maintains a chlorine residual?
Yeah, I think we like also like leverage a lot of existing like research and practice on stored drinking water practices. And so we want to like continue that messaging to cover your containers, use like clean containers, as well as like some of in our own messaging as well. Like we instruct people to not necessarily like store drinking water for like weeks at a time. And so you want to collect it more recent than that.
Thank you.
Thank you.
Thank you, everyone.
Yes, thank you so much. Thank you, everyone. That was our final presentation for today. I'm going to do the last plug of the day for this Audience Choice Award. And please fill them all out. If you have not seen a presentation, do not fill it out and submit all those. And then join us tomorrow, the same time, same place. We have even more presentations. And then the winners of the 3 awards that I talked about, the Impact, Innovation, and Audience Choice, those will all be announced at the Thursday plenary. I think that is all of the housekeeping. Again, if one of your questions was not answered, feel free to stick around or come to the Business Connect booth and we can direct you to who you need to see. And I believe that wraps up for today. So thank you so much for joining. Yeah, yeah.
I'm just gonna put it on stage.
Sure, I'm not really in charge of that stuff. This gentleman back here, keep in charge, maybe he could